Hi, let's talk about implementation of open addressing. Here we are expecting a very simple implementation. User specifies the size of the hash table when user creates an object. So we need to create a class myHash, and this is use of your class. This is how your user is going to use your class. User is going to create an object of myHash, and user is going to specify the capacity of the object. Right here, your hash table is going to have 7 elements at most. And then user is going to insert some items. Say user inserts 49, 56 and 72. Your hash table is going to look like this: 49, 56 and 72. -1 value I have used here to indicate that it's empty cell in your hash table, right? It's an empty, these are empty cells. Now, if user searches an item, say user searches 56, then 56 is present, the function should return true, right? So your output for this should be yes. Now, if user erases 56 or deletes 56, and then if user calls search for 56, so once the user deletes 56, we need to mark it as deleted. And for deleted, I'm using -2 here. I'm assuming that -1 and -2 are not present as keys. Now you must be wondering, how would you implement if -1 and -2 are also presented as keys? I'll talk about that by the end of this video. Here I am assuming, or you may also assume in your implementation, that -1 and -2 are not present as keys. We are talking about very simple implementation here. Also, now you must be having this question in your mind: what if user does not provide capacity? Because in library implementations like unordered set or hash set in Java, we don't have to specify the capacity, right? So for those cases, we can use dynamic sized arrays internally. We can use a vector or an array list for implementation. But here again, in this implementation, I am going to keep things simple. I am going to make a normal simple array, right, where I'm going to create the dynamically allocated array according to the size specified by the user. So this is the requirement of this function, and this is the internal representation which you are supposed to make, right? You may assume -1 and -2 are not present. -2 means deleted, -1 means empty. Now please pause this video and try to create a class myHash, and inside this class write all these functions. Write a constructor that creates a hash object of the given capacity. Write the function insert, write the function search, write the function erase, right? And you might also want to write a function print, that just for debugging purpose. What are the contents of your array after you have done some operations? So please pause this video and try to write down the whole class in either C++ or Java. Here is implementation of myHash in both C++ and Java. I have not written these functions: search, insert and erase. I am going to talk about these functions separately one by one. Here is only skeleton of the myHash class. So you can notice that we have an array. We don't specify the size of array when we declare it. Here we have a pointer which is going to have address of a contiguous location. Then we have capacity of the hash, and then we have size of the hash. And in the constructor, we are going to receive capacity as a parameter. So I have a parameter C which receives capacity as user input. Now when user creates a myHash object, user is going to provide the capacity. We initialize the capacity as C. We initialize the size as 0 because initially hash is empty. Then we initialize all array entries as -1 because everything is empty initially. -1 means empty, -2 means deleted, and other values means the cell is occupied. Now I've written a simple hash function which is key ampersand capacity. So if capacity is 7, we are going to have key ampersand 7 as a hash function. So this is skeleton. After the skeleton, I have written these 3 functions. I've not written codes of these functions. I've written ... So we are going to fill these ... and we are going to write these functions one by one: search, insert and erase. Now you have enough idea how these classes are going to be represented. You would like to write these functions yourself. Let us first see implementation of search function. So syntax for writing this function is almost same in both C++ and Java. The only difference is you need to read bool in C++ and boolean in Java. And please remember this function is going to be defined inside the class, right? Because it's part of the class. Now let's talk about this logic of search function. So logic of search function is simple. We'll first compute the hash for a given key that we are searching. We'll go to that slot and check if the key is present at that location or not. If key is not present at the location, then we'll do linear probing. So in this implementation, I am going to talk about mainly on linear probing to keep the implementation simple. So we'll linearly search for next locations. And when do we stop? We stop in three cases. First case is when the key is present at a slot while you are doing linear probing, you will return true and you will stop. Second situation is when you see an empty slot, when you see a slot with value -1. Please remember, we do not stop at a deleted slot as we have discussed in the open addressing video. We stop at an empty slot, right? So we stop in three cases. One is when you find the key, when you see an empty slot, and the third case is when you have traversed through the whole hash table. You started at some location and say your whole hash table is full and you kept on doing linear probing and you came back to the original location, then also you need to stop. Otherwise, you will keep on doing the traversal in an infinite loop. Please remember, it's not a normal array traversal, it's a circular array traversal, right? Because in linear probing, when we insert also, if I am looking for a location, say index 6, and if the 6 is occupied, what I'll do is I'll circularly start looking from this location. I'll come to here, and then I'll insert here, right? So this is how everything works in open addressing. So let's see the implementation now. It's super simple. We first compute the hash for the given key. Then we run a loop which begins with the given hash index. So say I'm searching for 63. So my hash is going to be 0. So my I is going to be beginning from 0. Then I'll run a loop while array I is not equal to -1. And inside the loop, I'll compare array I with key. So I'll compare 49 with 63. They're not matching. Then I'll go to next index in circular manner. So I'll come here. It's not matching. Then I'll come here. It's not matching. Then I'll come here and I see it's matching. So I'll stop, right? I'll stop and return this index 3. Now say I'm searching for something like 64, which is not present, right? So I'll get the hash as 64 means you will get the remainder as 1, right? So you will come here. It's not matching. Then you will come here, not matching. Then you will come here, not matching. Then you see a -1. So you will come out of the loop, right? You have the loop termination condition while array I is not equal to -1. So we'll come out and you will return false. Let's now talk about a case when your hash table is full. Say you have entries as 70 and 77 here, and say now you are searching for 64 again. So you will search for 64, you will come to the slot, right? Remainder is 1, you will not find it, then you will come here, 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 you will come here, and then you will go in a circular way and you will come here. You will not find it here as well. Then you will come back to this point. When you come back to this point, you will return because you have come back to this point. So that's why we have this condition. If I becomes h, right, I equal to I plus 1 mod capacity, and if I becomes h, you return false. So this is the implementation of search function. Now please pause this video and try to write down insert function yourself. Here is implementation of insert function based on linear probing. Please note that we are going to talk about linear probing, simple technique in all the implementations here. So insert function returns a boolean value here, right? Bool in C++ and boolean in Java. This function returns true if it could successfully insert the key, otherwise it returns false. Now what are the cases when it cannot successfully insert the key? The cases are when your hash table is full, and other cases when the key is already existing in the hash table. So first thing we do is we check if size is equal to capacity, then we return false, that the hash table is full. And otherwise we first compute the hash function. After computing the hash function, we do start linear probing. We start from this location I and we keep on linearly probing for an empty location. And when do we stop? When we find an empty location, or we find a deleted location, or we find the key present in the hash table, right? In these three cases we stop. If we find an empty location, we can insert it. If we find a deleted location, then also we insert it. Please note that search does not stop at deleted location, right? But insert does, because as we've discussed in the open addressing introduction video, because insert can insert an item when a slot has been deleted. So when we come out of the loop, one of these three cases might be true, that it's an empty, it's a deleted, or array I is equal to key. If array I is equal to key, it means key is already present. So we return false to indicate that we could not insert the key and key was already present. Now, if these two conditions are true, we came out because of one of these two conditions, then we simply insert the key at the given index I, right? I because of which we came out, and we do size plus plus and we do return true. Let's see how does this work for this example. Initially our hash table is empty. We try to insert 49. So our size must be 0 initially, right? Because it was empty. That is how we initialize the constructor. So when we do 49, we come here, we get the hash function as 0. So we go to this location, we begin our loop from this location, and this is -1. So we immediately come out of the loop. And it's not equal to key, it's -1. So we insert 49 here. And we increment the size to 1. Now we search 50. So we again compute the hash function and we see it's -1. So we come here and increment the size. So 50 is inserted here and size becomes now 2. Now we insert 63. This is an example of linear probing. So when you insert 63, you compute the hash function as 0 and you go to that location. It's not -1, it's not -2, and it's not 63, right? It's 49. So we go to the next location here. It's again not -1, not -2, not 63. So we go to the next location here. And this time you see a -1. You come out of the loop. When you come out of the loop, you check whether this is equal to key or not. It's not equal to key. So what you do is you insert 63 at this location, right? And you do size plus plus. Your size becomes 3. Now 64. So 64 means remainder value is 1, right? So you will come here, then you will come here, then you will see a -1. So you will insert 64 here, right? You will fall into this case. Now 69. 69, you will directly come here and you will insert, because 69 modulo 7 is 6. Now 68. 68, you will directly come here and insert 68. Now suppose you were trying to insert 63, which is already present. So what you will do, you will begin from here, then you will linearly probe, you will come here, you will come here, and you will see that 63 is same as key, right? So you will come out of the loop and you will fall into this if condition, you will return false, that it could not insert 63. Size must have been 6 by now. So if your hash table is full and if you try to insert an item, you will return here itself. Suppose I insert one more key and then if I call insert, then it will return false. So this is the implementation of insert function. Now please pause this video and try to write down erase function yourself. Here is implementation of erase function. If you take a closer look at it, you can notice it's almost same as search function. We are very close to search function. The only extra added line is this one. In erase function also, we first compute the hash for the given key. Then we do linear probing one by one and try to find the key. If we do not find the key, if we come back to the original slot from where we started, we return false, that key was not deleted. And while doing the linear probing, if we find the key, then we mark the slot as -2 and we return true. Right? That's the simple logic. Let's understand it with this example. Say we have this hash table, we wish to delete 50. So we'll compute the hash function, we'll get the value 1 and we'll mark it as -2. This is deleted now. Now we want to delete 63. We'll come to the slot. We'll do linear probing. Please note that like search, we do not stop at -2. So we'll continue from here. We'll come here, and we'll mark it as -2. That this has been deleted. Now erase 64. So 64 means this hash value. This is -2. So we will continue. We'll come here. We'll come here. We'll come here. We'll see a -1. So we'll come out of this loop, right? Because we see a -1. So we'll come out and we return false, that the key is not present. We could not delete it. So this is how this erase function works. It's simply similar to search function, does the linear probing to find the key and delete the key. And when it deletes, it marks it as -2. So we have talked about simple implementation of open addressing where we used fixed sized array and linear probing. Let's now see an interesting question. The question is, we assumed that -1 and -2 are not our input keys, and we were comparing keys with -1 and -2. What happens when -1 and -2 are actually our input keys, part of our input keys? So how actually libraries implement this open addressing? The fact is, in library implementation, though you don't use actual keys to store at the slots, you use their pointers or references. Pointers in C++, references in Java. So empty can be quickly checked by checking with null. If your slot is empty, then it should be null, right? Like -1 is not required at all because we are storing object references or pointers. Now the next question is, how do you handle deleted? Now please pause this video and try to think of an approach yourself. How will you handle deleted? So this is an interesting solution. What library implementations typically do, they create a dummy node inside their class. So this dummy node is part of the class and shared by all the functions. Now when you delete something, you store reference or pointer to this dummy node. And it's a fixed node. So every time you want to check for deleted, you can check for this dummy node. That's the idea that library functions use.